Welcome to another video on related rates. So we're just going to do another example. So in this example we have a 5-foot ladder resting against a wall. So there's our wall. Assume the wall makes a right angle. So we have a ladder, it's 5 feet, resting against the wall, and then the bottom of the ladder begins to slide away from the wall. So it begins to move in this direction at a rate of 2 feet per second, and then we're asked how fast is the top of the ladder sliding down the wall. So as this moves this way, the top of the ladder, that would make sense, moves down the wall. So, and we're given, so we're only given the, well actually, you know what, we're going to need one more piece of information. We'll say when the bottom of the ladder. So this is part of the question. There isn't enough information as it is to solve the problem. Is let's see, 4 feet from the wall. So that's the question. So you need this information to solve the problem as well. So okay, let's give these variables. Let's let x be the distance from the bottom and y be the distance from the top. So what are we given? Well, we're given how fast x is changing, right? We know dx dt is changing at a rate of 2 feet per second. What do we want to know? We want to know how fast dy dt is changing, and we want to know it when x equals 4. So that's that information that I just gave you that I said you needed to know to solve the problem. So now we need an equation which relates this rate and this rate. Well, originally the equation won't relate the rates, it would just relate x and y. So what equation do I have that relates x and y? Well, right angle triangle, that might suggest to you x squared plus y squared is equal to, and now 5, it's equal to 5 squared, right? And 5 squared here would be a constant. Right, 5 is not changing, so that's not a rate of change. It's constant. So now we'll do the same thing. I want dx dt, so I'm going to differentiate both sides with respect to t. So what's the, well, how do I do the derivative of a sum? Well, it's just the derivative of each sum. And then the derivative of 5 squared, well, it's a constant, right? So that's 0. The derivative of x squared is 2x, but it's with respect to t. So dx dt plus 2y, same thing, dy dt. So now this I know, this I want to know, this I know, this I don't know. So there's two things here I don't know. Well, that's no good. I need to know, I can only have one unknown, but we can figure this out. We can figure out y. How can we figure out y? Well, remember, x squared plus y squared equals 5 squared. And we know that x is equal to 4. So 4 squared plus y squared equals 5 squared. So that'd be 16 plus y squared. You might know your Pythagorean triples and already know the answer. So I'll just write 25. So subtract 16 from both sides. So y is equal to 3. And it's positive 3, right? Square root, you might say plus or minus 3, but it's a length, so y has to be equal to 3. So now let's just sub in everything we know. 2 times x was 4. So that's, remember when we said we needed this information, that x was equal to 4 to solve the equation? That's why, because we need, otherwise we'd have far too many unknowns. Dx dt is 2. 2 feet per second. You could leave the units in there if you want. It's just going to hurry up our calculation, so I won't. And then dy dt is our unknown. And now we'll just sort of rearrange everything. So it'll be 16 plus 6. Subtract 16 from both sides. And divide by 6 on both sides. So divide by 6, divide by 6. So minus 16 over 6 would be minus 8 over 3. And then the units on that, I forget what we were feet per second. Feet per second. So minus 8 over 3 feet per second. So we're sliding down the wall at minus, I don't know if you can see that. Whatever. Minus 8 over 3 feet per second. Per second. It's an S. So just, quickly to mention, why did we get a minus? Well, we got a minus because y is decreasing, right? We're moving down. So this distance y is getting shorter, so it's changing in a negative way. So if you were to answer the question, though, how fast is it moving down the wall, you'd probably say it's moving down at 8 over 3 feet per second. Or you might sometimes, with these sort of physical examples, a decimal might be a more useful measurement. So minus 2.67 feet per second. So that might, be more meaningful to you than minus 8 over 3. Or, you could always do a mixed fraction. Minus 2 2/3 feet per second. So all those are equivalent.